This video, we will be going over and working through the evaluator. So that is the last piece of the puzzle. Once we have this, we'll have a semi-functional interpreter. It'll be able to do mathematics, comparisons, basically just like simple operations. So first, in this intro section, I will just explain what the interpreter is, what the evaluator is, and then we're going to go to the footage of me actually working on it, getting frustrated as per usual. So thank you for watching. Please like and subscribe. So the evaluator, that is basically what actually does all the execution of the code. So it goes line by line and executes each line of code one by one. And it's the last piece, and well, kind of the last piece. It could possibly be, there could also be more steps, such as like optimization, different other things, different passes, compiler passes that change the code, get rid of code that's not used, make it more efficient, that type of stuff. So it's really endless how many passes you want to have, but for our purposes right now, we're just going to say this is the last part. My hair is doing weird stuff. Ignore it. Don't pay attention to it. The the evaluator's job is to evaluate expressions and statements. In this video, we're just going to evaluate expressions. We'll move on to statements a little bit later. And then after that, we'll decide what we have to do after that is decide how we're actually going to represent the code in our language. So I made a little table. It's pretty self-explanatory. So any value in our interpreter will be represented by any in Swift. Null will be represented by nil, boolean by bool, integer by int, float will be a double, and string will just be a string. And on this next slide, I have some example code of how the evaluator will work. It'll be pretty simple. We're just gonna pass in an expression. We're going to check what kind of expression that is. Say it is a binary expression. We're going to return whatever evaluate binary does. So all we're doing in here is setting the left and right side to an instance variable, a local variable. And then we're going to switch on the type of operator. So if it's a plus, we're just going to check to see if it's an int. If both sides are an int, then we're just going to return what those two ints are added together. And then, and I'll show this in the code I already recorded. If it is like something else, say a float, two floats, we can add those together. If it's a float and an int, we can add them together. If, say, it's an int and a string, we can't add those together. We can decide how we want to handle that. In the video, I believe I did not handle that and just threw an error, but say you wanted to cast the int to a string and then add it to another string, you could do that here. But yeah, if there's two strings, we're just going to concatenate the two strings together. And that's about it. So let's go back to Durag Maddie, writing code and being upset. Okay, so I am back again with another video. So last video, we had some technical difficulties. Let's pretend that never happened. It didn't happen. This video, I am trying a new setup, so I'm just screen recording and I'm recording on my camera. Hopefully this will be better than using OBS on Mac, because that stunk. So last video we were working on our parsing of expressions. We got to, we were able to finish all of them. So now the next part will be evaluating those expressions. Let me go grab my book. This section should basically create a calculator for us, so we'll be able to do basic arithmetic using our interpreter. So this will be the first step in having kind of a full interpreter. It won't be super feature packed, but it'll be able to do some stuff, and that's better than no stuff. First thing is evaluating literals. So let's create a class for actually evaluating things. So we're gonna call this evaluator. The book calls it the interpreter, but I called the project the interpreter. So we got class evaluator. So what evaluator is gonna do is just walk the tree and evaluate different things. So we're gonna need to take in what the parser returns. So that's gonna be a program. And then we're gonna have a function. Well, first we have to init, and then we have to have a function, and that I will call eval, and boom. So eval will actually evaluate things. So the first thing that we want to evaluate is literals, and to evaluate a literal, it's just a literal. So if it's a number, it's just a number. If it's string, it's a string. So let's see. Okay, so I think I'm gonna kind of go my own way when it comes to evaluating. So the book uses the visitor pattern. I would recommend, if you're following the book, just follow that. I think I'm gonna keep it a little bit simple and just kind of loop through the statements and just evaluate them based on what type of statement they are. So let's see. So right here I have a function that is called evaluate or eval, and then I'm just looping through all the statements in my program, and then we are applying to throw errors. So we're gonna create an error enum. So runtime error. I'm just gonna add like a general error for now, and add more specific errors if needed later. So different kinds of statements that we have so far. So if we look at our abstract syntax tree, different kinds of statements are functions, expression statements, and that is it right now. So that makes it kind of easy. So we're just gonna say switch. We're gonna pass in the statement, which my voice just cracked. Switch statement, case as function. So if it's function, we're gonna do something. If it is a expression, we're gonna do something else, and then we're gonna have a default that just throws that error. So we're just gonna throw an error if it doesn't work, and then I have to make runtime error an error. Okay, so for a function, we're just gonna say eval func throws. Okay, and then expression, we're gonna say func eval expression. Okay, so boom, we have these two cases, and we're again gonna pass in the statement, but this time it is a function, and this time is an expression statement. Okay, so statement. Okay, so let's just do expressions first, because that's gonna be easier. So we're gonna go ahead and, well, actually, we're not gonna do functions at all. This chapter does not cover that. So we're gonna say so we're gonna say test expressions. Okay, so we're gonna grab our boilerplate here. And then for statements, we're gonna say 1 + 2, 2 times 3, maybe. And let's just start with those two and then expand from there. So we're gonna say parse. I forget what eval even returns. It doesn't return anything at the moment. So let's take a look. All right, first we're gonna pass the program, then we're gonna try that eval. We're gonna run it, and how should I test this? Okay, so I think I need to make a decision on how I actually want to evaluate things. So for now, I think we're just gonna create like a class or a method that will, after it evaluates the stuff, just print out like the Okay, all right, I see what's going on in this chapter. Right now the evaluator is only able to evaluate one expression at a time. So we're actually gonna we're just gonna take that out. And then for this, we're gonna so instead of doing all this, we're gonna say we're just gonna evaluate expression statements, since functions are not really a thing just yet. So let's see. Well, it's gonna hit this anyway. So from here, we want to say. So okay. So all right. So we're just gonna do another switch statement. First, we're gonna get the expression though. So okay. So. Okay, so take a look at our abstract syntax tree. Different kinds of expressions we have right now can be anything from assignment, binary, unary, integer, boolean, string, val, float, null. Okay, so we just gotta say, right now we're just gonna start with binary, and then we're gonna have a default that throws an error. So okay. So what we're gonna do is I'm gonna say try binary. Okay, so we're in here. From here, we know that so we know it's a binary at this point. So we want to grab the operator. So that'd be this left side. Just doing this to minimize typing. So. Do that, switch on the operator's type. So we're gonna say, so binary operations can either have a plus, minus, star, slash, or I think that's it, yeah, at the moment. All right, so what we have here is we know if it's a plus, then we have to add stuff. So how do we... Yeah, so we actually want to call evaluate recursively on this. So let's actually do it like this. Okay, so here we just move this into its own method. That way we can call that on there. So we want to call evaluate expression recursively because it could contain another expression. So we're gonna do that. Okay, so we're gonna say left. Okay, so this is actually gonna return any, I believe. So, because it can be anything. So, just gonna say left plus right. Oh, okay. Yeah, we aren't returning anything from this. So we're gonna do that. So, yeah, we wanna make sure this is these are two things that can be added together. So we're gonna say. All right, first of all, we're just gonna do integers, and we're gonna have to do dot value. Okay, so, and then there's gonna be there's definitely a cleaner way to do this. Actually, we're just gonna leave it at integers right now, and then from there. Okay, so right now we are, so actually we're gonna also return from here, okay? And then, so I'm actually not gonna do anything just yet. So we're just gonna create an unimplemented error. So yeah, we're gonna do that. So for now, we're just gonna actually return whatever is the last thing. So, okay, so what we're doing is looping through each statement, evaluating each one, setting it to whatever was the last thing returned, and then we're just returning that from here. So we're gonna say make that optional because it may return nothing. Okay, so I believe we can pass this in, and eval should equal 3, and then I'm gonna set 2. So that. Else turn. Oops. And then fail on purpose here, just because we know that we didn't get what we wanted. And then here we're gonna say expect answer equals 3. So we're gonna see if this guy worked. So we're testing. Okay, so let's see what happened. So looking like through an error. So that is where the error happened. Let's run it again. See. Oh, yeah, we're not handling integers. So the case. Okay, so we're just returning the value here. So actually, I believe we can just say this is just int now, not the integer struct that we created, because it's gonna be evaluated if I'm thinking correctly. So we're gonna go delete all these values. Bill failed. Cool. Okay, that worked. So I'm actually gonna make sure it actually fails if I put the wrong. Cool. Okay, yeah. Okay, so that's working. It is evaluating 1 plus 2. So actually gonna turn this into a parameterized test, I believe. So we can actually test multiple ones. I haven't really traits. How do you do that though? I gotta Google real quick how to do a parameterized test in Swift. Yeah, I don't actually fucking know how to do this. Okay. Oh, okay. So I think I know how to do this. So we're just gonna say, okay, cool. So that's a cool little feature of the new Swift testing framework. So you can just add in different parameters and then have those tests run for different things. So let's do 2 times 5. That would equal 10. So if I run it again, check that works, and let's see, failed expectation. I don't know how this works. Why did it work the first time and not the second time? Yeah, okay, so that works. I dead ass don't understand what's going on, because I feel like I'm doing this right, but the tests are giving me the wrong answer. It has to be a bug, some kind. Oh, so it's actually hitting every permutation, and that's why it's failing. What if I just want to do 2? This is not actually helpful. Fucking all. Alright, okay, what if I do this instead? So we go boom, because this shit just wants to act stupid. Alright. Okay, well, it's not the prettiest way to do it, but it did work. So, okay, so now we can ignore this, because that is, seems like it's still like having like the failed test linger. Okay, so all right, so multiplication, let's test division. So let's see, 10 divided by 5, and that equals 2. And then subtraction, we're gonna say 5. Okay, cool. So all right, we're getting what we expect from this. So we're able to do basic math. From here, we can evaluate unary expressions. So let's write a failing test here. So -1, and that should equal -1. That last one's gonna fail because we haven't implemented unary expressions. Yep. Okay, so let's go ahead and do that. That should be fairly simple. Let's unary. Let's create a method for that. So return unary, pass in the expression, choose throws, and we will say operator equals expression dot operator let right, and let's see, switch on op dot type base b bang and minus default is throw an error. Okay, so we're gonna say if it is a bang, then we just want to say, oh, actually we want to do, there we go. So say let right will right as int return here. So if right equals right as an int, then we want to return. Actually, we don't, because you can't do that for you can only do the not on Boolean, and we haven't implemented that yet. So instead, we're just gonna throw runtime error for unimplemented. We'll come back to that. And now let right equal right as int. Then we are going to return, we're gonna return minus right. So that should make our test pass now. Correct. All right, anything else that would be easy to implement right now? Oh yeah, we wanna do parentheses as well, and also different kinds of literals. So what am I at, 48 minutes? Okay, so I think that this is fairly self-explanatory what I'm doing. All this code will be on the GitHub page, but for now, I believe I'm just gonna do the rest of this off video. And I've been thinking about this series a little bit, and it's been fun, and I'm gonna keep doing it. But I think I want to make a more like comprehensive overall, this is a interpreter video, rather than just watching me struggle through coding it. Maybe I'll do like a longer video that kind of explains everything, or shorter, I don't know, we'll see. But stay tuned for that. I believe I'll just like keep doing the daily uploads though, as far as this, as I'm working through this. But thank you for watching. When I come back, we're gonna continue to evaluate things, probably parse more things like functions and stuff. So stay tuned. Thank you for watching. Thank you for subscribing. Thank you for liking. I've been Maddie. I will see you next time.